Hello, dear students. Uh, I hope everyone is doing well and fine. I welcome you to a very unique semester for our both the faculties and the students of online courses. So this time I'm going to teach you Open Channel Flow, which is an elective subject and against of the traffic engineering. So I think 21 students right now enrolled in this course. So let us be hopeful. Let us try to understand what is open channel flow. Already you have been briefed about open channel flow in a subject hydraulics and hydraulic engineering. So I hope this detailed course will refresh your memory and open up the conceptions about open channel flow, and we'll see when we proceed throughout the course. We'll start learning stuff, we'll start learning together, and we'll be discussing and interacting throughout the whole semester. Okay, so now the process of this new strategy of teaching or learning process is that what we have been deciding and planning to do is first, suppose on the day of the class, on the allotted time, we will be coming and interacting on Google Meet, and we'll just discuss about the notes that I've given to you and anything we can do for a few minutes or depending on the topic of discussion. And on the previous day of the class, I'll be giving you a lecture video, and it is not that I will only give you video lectures every day. There might be some PDFs, some PPTs itself, which are self-explanatory, and we can also discuss those PDFs and PPTs in the next class while we interact. And also, at the end of every class, you will be given few questions regarding on the topic that we have covered, and submitting the assignments successfully will assure your attendance in the class. So let us see, and let us be optimistic that we can easily cope with this new system, both you and me. So let's start. So open channel flow is a very, very, very important course in water resources engineering, also hydraulic engineering, because it deals with a lot of factors, parameters, and behaviors of how a open channel flow behaves in nature. So let us start. First, let us go through the syllabus. There are 4 modules in total, and module 1 will basically be dealing with the basics and introduction of open channel flow and what are the different types of governing equations that are used in open channel flow. And so we'll go through different equations given by different scientists and researchers, and we'll talk about different channels and the relationships between different parameters. Module in module 2 we'll be specifically talking about the energy of the open channel flow. How and what is the energy, how the energy affects in the open channel flow, and what are the different types of parameters that affects the energy. So that will cover our module 2. Module 3 will be talking in details about ZVF, which is known as gradually varied flow, and all the equations and theories and science behind this gradually varied flow. And module 4 will exclusively deal with rapidly varied flow, and what is the behavior of rapidly varied flow, how we can classify it, what are the different characteristics. So in that manner we'll proceed. Now let us have a bit of flashback, a very basic flashback of to start this course with. I am sure you all know these topics that we're going to see, very few topics. First, let us make our concepts very clear. What is fluid? So a fluid is the substance that deforms continuously when subjected to a shear stress, no matter how small the shear stress is. That means we, in general, we can say that fluid is something that flows, but to be more technical in nature, because you are all now advanced learners, you are all in the final year, so we'll go with a very technical definition, that it is a substance that deforms continuously. The deformation does not stop. So a fluid is deforming. Suppose I have a phone in my hand. If I try to bend it, it will deform and it will break. It will not deform continuously. It will deform up to some extent and it will break. But a fluid is something that deforms continuously. Of course, if the shear stress is present. However small magnitude the stress might be, that is not the concern. But if there is stress, there will be deformation. So we all know what is shear stress and shear force. So I'll not go into that. Classification. So fluids. There are two types of fluid in particular. One is ideal and one is real. So ideal fluids does not exist in nature. You will not find ideal fluid anywhere in the world, but this is just an assumption to make our analysis simple. So ideal fluid are those which are incompressible with zero viscosity and shear stress is always zero. Ideal fluid is hypothetical. So I have already told you there should be some shear stress to for the flowing fluid. So shear stress cannot be zero and viscosity cannot be zero. Viscosity is what? Viscosity is just a resistance to flow. There will be some resistance that is offered by the other objects or the medium to the fluid to give some resistance to the flow. So it cannot be zero, but this is a very important type of assumption we deal with, because to simplify our analysis. Now, fluids with viscosity are known as real fluids. Very simple. Water is a real fluid, milk is a real fluid, honey is a real fluid. These are viscous liquid that is found in nature. Again, the real fluids are classified as Newtonian and non-Newtonian. Before we go into that, let us talk about one thing very clearly. In fluid mechanics, when you have studied in fluid mechanics in third semester maybe or fourth semester, we have dealt with fluids in general, but in open channel flow we are dealing with only water. So we have eliminated all the other types of fluid and we are dealing with only water. That is, water is flowing in an open channel. Okay, so there are two types of real fluid. One is Newtonian and other is non-Newtonian. Newtonian fluid is nothing but the fluid that follows or obeys the rule or law of viscosity, Newton's viscosity. Okay, Newton's law of viscosity. So this law states that shear stress is equal to uh, shear stress is equal to mu du by dy. Okay, so this is the relation that is given by Newton. Okay, which, if a fluid follows this type of equation, if a fluid obeys this law, then that fluid is known as Newtonian fluid. This is nothing but, that means if a fluid is having a shear stress, okay, and a viscosity, then the fluid is known as Newtonian fluid. This viscosity here, tau is shear stress, mu is viscosity coefficient, and du by du by dy is the velocity gradient. Okay, so there is some velocity which is changing with the height. Okay, this is y is the height of the fluid. Viscosity, mu is the fluid property and is known as dynamic viscosity. Okay, so mu is the viscosity coefficient which is known as dynamic viscosity. Now this equation 1 is known as Newton's law of viscosity. The kinematic viscosity mu is given by the ratio of dynamic viscosity to mass density. Suppose we divide this dynamic viscosity by the density of the fluid, that is the density of water, then we get the the kinematic viscosity. Okay, so this is the relation of kinematic viscosity. This is known as nu. So some examples of non-Newtonian fluid. So non-Newtonian fluid is something that a fluid which does not obey this relation, okay, is known as non-Newtonian. Our examples are thixotrophic substance, okay, ideal plastic, Bingham plastic, pseudoplastic, dilatant substance. So this, all these objects that we are seeing, they actually are artificial objects. Okay, this is not very easily found in real nature. That's why non-Newtonian fluid very rarely exists in nature. But this quicksand, if you can see, it's written quicksand. Quicksand is a condition of soil when the effective stress is zero. If this is found in nature, okay, so non-Newtonian fluid is a fluid that does not obey the law of viscosity. Now, what is thixotrophic substance? So the thixotrophic substance is a substance that is changing with time. Okay, this changes the properties with time. So uh, I've given one question regarding this thixotropic substance. Okay, so I want all of you to go through it and write a very short answer about what is thixotropic substance. So this is it for today. Just a very introductory class or a lecture, if you may. So today is 5th. The class date is 5th. The first class is 5th, day 1. So there are two questions that I've given. Water is the example of what kind of fluid? Whether it's a real fluid, whether it's a viscous or a Newtonian fluid, or all of the above. Second question is, what are thixotrophic substances? So you go through it and you write a very short answer about the definition or example if you want to give. Okay, so these assignments you have to submit in Google Classroom itself. I will be giving this question as an assignment in Google Classroom. So after you have watched this video, go to Google Classroom and access the assignment and try to complete it by tomorrow. And tomorrow's class is at 1:50. So we will be meeting around at 2:30. Okay, will it be okay by you? 2:30 or 2:15? I'll be informing you in the WhatsApp group. So I hope the first class have been interesting, though we have not covered enough till now. So let us have a good session this year. Take care.